everybody. So we are going to be talking about identifying polyhedrons today. And for these polyhedrons, I'm actually going to be showing you all the different types in person and on your screen that go along with your notes. All right. So first off, let's talk about what a polyhedron actually is. So a polyhedron is a three-dimensional shape with flat polygonal faces, straight edges, and sharp corners. So if I were to hit myself right here, it would hurt. Or we call them vertices, points, vertex. It's a plural of vertex. So your first shape looks like this. In fact, the same thing that I've had in my hand. This is the base of it. And it's got three different faces and the same base on the other side. This is going to be called a triangular prism. Triangle as the base and the prism because it prisms up. So is this considered a polyhedron? Yes, because it's got polygonal faces. These are just rectangles on the side, triangles, triangles, sharp edges. I could really hurt myself. Right here, I could hurt myself here on the corners because vertex. So, yes, this is a polyhedron. How many faces does it have? So, a face would be 1, 2, 3 on the side, 4, and the fifth one is our last purple one right here. It's going to have 5 faces. The edges are where all of these faces intersect, where these planes will intersect. So I've got 1 down here, turn it, 2, turn, 3, and then 4, 5, and then 6. But then I've also got 7, 8, and 9. So I've got the 3 of my base, 3 of my other base, and then 3 from the sides because both of these bases are suddenly dropping the height down. And those are considered edges. So we've got a total of 9 edges. Your vertices, you're going to end up having 6 vertices because they intersect at 1, 2, 3, 4, 5, 6. It's where your edges intersect. All right, so next we've got a rectangular prism. Looks something like this. Now, a rectangular prism can also, can also be a cube right here. Okay, so as long as the main base is a rectangle, it doesn't matter. And check this out. This rectangular prism looks different than this one because they've got 2 different types of bases here, but they're still both rectangular prisms. So first, because of these sharp edges and vertices and all the polygonal faces right here, we're going to say that yes, this is a polyhedron, and we're going to count up the faces, 2 on the base, 4 on the side, so you've got 6. Count up the edges. I've got 4 on the top, 4 on the bottom, 4 around the side. So I've got 12. And I've got 1, 2, 3, 4, 5, 6, 7, 8 vertices. All right. So not so hard. You guys have been seeing this forever. And we're just kind of labeling them and identifying them. All right. Here's this next one. And this next one is a pentagonal prism. And I actually don't have this shape, unfortunately. Sorry. Sorry. But we can still figure it out. And if it helps you, you can always color them in. And we'll be doing a lot of coloring as we're going through the unit. So notice, here's my base, which is why we're saying this is a pentagonal right here, prism. Because those 2 pentagons are our bases of this prism. Because we've got sharp edges, flat surfaces, And they're all polygonal faces. This is, yes, it's a polyhedron. There are 1, 2 faces and 5 on the lateral, which means we've got 7 faces. And then edges, we've got 5 around the top, 5 around the bottom, and 5 on the side. We've got 15. And the vertices, you've got 5 on top, 5 on bottom. So those are these right here. Okay, it's where they intersect. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now a different one that we've got is that this one, this prism, so to speak, has a circle for a base. All right, this is called a cylinder. This is something you've learned last year, or well, actually 2 years ago, but this is a cylinder. You see these a lot. Our Coke cans are cylinders. All right, now in order to determine if this is a polyhedron or not, well, first we're going to realize that there aren't really any sharp edges here. You know, literally, if I were to drop this right now, it would just keep rolling and rolling and rolling. Whereas with the pentagonal or the triangular or the rectangular prisms, these, when I put them down, they just kind of stay. They don't roll. They're very flat and stationary. So think about it that way. Therefore, this cylinder right here, not a polyhedron. Which means we can't say how many faces there are, we can't say how many edges there are, and we can't say how many vertices there are. You are working with technically 3 different sides because you've got 2 bases right here, and then you've got the lateral that's wrapping around. All right, next up we have got a sphere. Now a sphere is a ball, so you already know that this is not going to be a polyhedron, because literally if you drop a ball, it's gone. It's rolling. It's already off into the other room. So no to that one. All right, now let's check out some other shapes right here. These are pyramids. So pyramids have one base, and then they all come together to one vertex at the top. So we've got a triangular pyramid because it's got a triangle for a base. And so all 3 of the vertices of that triangle come up to one main vertex. Because it's got look, it stays still when I landed on something. It's got sharp edges and sharp points, and each face is some type of a polygon, then yes, this is a polyhedron. In terms of the faces, there is going to be 1 for the base, and then 1, 2, 3, however many there were right here. And I can usually figure that out. I do 1 plus the number of sides of that pentagon at the bottom, or I'm sorry, that polygon at the bottom. So we've got 4 faces. Edges, guess what? 1, 2, 3, 4, 5, 6. I wonder if you can pick up the pattern as we keep going. In terms of the vertices, you've also got 4. 1, 2, 3, 4. All right, so next up, we've got a rectangular pyramid, and your base right here can also be a square because that is still considered a rectangle. It's got its 90-degree angles, all right, and its opposite sides are congruent. It's got flat surfaces, sharp edges, doesn't roll away, and pointy vertices. Therefore, yes, this is going to be a polyhedron. The faces, let's count them up. We've got 1, 2, 3, 4, 5. Edges, we've got 1, 2, 3, 4. And then we've all got these right here that are going up from it. I'm sorry, that was 4. So 5, 6, 7, 8. So again, that's 1, 2, 3, 4. Then go up 5, 6, 7, 8. Your vertices, you've got 1, 2, 3, 4. and one on the top. So I'm hoping you can pick up this pattern. We've got a couple more. Next up, you've got a pentagonal pyramid. And that's because the base of this is a pentagon. All right? So, yes or no if it's a polyhedron? I'm going to say yes because polygons on all the faces, sharp edges, sharp point. In terms of the faces, there are going to be 6. There are also going to be 10 edges. Again, I'm hoping you can catch that pattern right now. The vertices, also 6. Now, pyramids, it's super easy to catch on to this pattern. So, for example, if I were to give you a hexagonal pyramid right here. So, it's got a hexagon for a base, comes to a point at the top. All right, so think about it. We know it's going to be a polyhedron, but how many faces will this have? Well, it's going to have one more than the number of sides. Hexagon, 6 sides, one more for the base, so you've got 7 faces. And in fact, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Sorry, I couldn't count for a second. All right, then your edges, you'll notice that you are going to have how many edges? And if you guess that you're going to end up having 12 because it's double, you're right. You've got 6 around here, and then the 6 that shoot up to that same center point. Your vertices are the exact same number of faces you have in a pyramid. So 1, 2, 3, 4, 5, 6, 7. All right, and that's one more than the number of sides. All right, next up, we've got a pyramid that's got a circle for the base. So similar to a cylinder, it's giving us a sharp point this time, but it's not really giving us any sharp edges here. If I were to put this down, it's going to roll off. Think of a party hat, or think of an ice cream cone. Those are cones, obviously, for that name. This is not going to be a polyhedron, therefore it doesn't really have faces. We can't count the edges here. There aren't any coming up. And vertices, not really happening. Right? There's this main point up here that it comes to, the apex of it. And then you've got your base, and that's it. And then finally, we've got this thing right here. And it's pretty much, if I took this sphere right here and I sliced it in half, which means, excuse me, surgery time. It's going to pop off. And now you've got a hemisphere. So I've literally chopped it off. Think about when you're cutting an orange in half. That is a hemisphere because you're cutting the sphere in half. All right. Think about the globe right now. We live on the Western Hemisphere, as it's titled. Is this a polyhedron? So again, we've got a sharp edge here, circle for a base. So we don't really have like necessarily a sharp edge. It's more smooth. I can roll it around. If I were to drop this, it's going to go. I'm not going to be able to stop it for a second. So this is not a polyhedron, so I can't count faces, and I can't count the edges or the vertices. All right, and that's all there is. Thanks for watching.